Hello students, welcome to Marine Engineering Tutorials. I am Atul Kumar Gupta and back with a new tutorial. Presently we are studying Marine Auxiliary Systems and Deck Machinery. Today we have 17th lecture and the topic is Suitability of Evaporated Water for Drinking and its Treatment. In this tutorial, we will first learn about the suitability of evaporated water for drinking purpose and the necessary treatments required. Then we will discuss about the mineralization of evaporated water. Next we will learn about the sterilization of drinking water with chlorination. Then we will learn about the sterilization of drinking water using silver ion method. Lastly, we will learn about the sterilization of drinking water using ultraviolet light. Let's discuss these through the following slides. Suitability of evaporated water for drinking purpose. Evaporated water on ship is nearly distilled with a very small amount of dissolved salts, below 10 parts per million. Water evaporated on ship is soft and deficient in minerals, thus it requires treatment before consumption. Why evaporated water requires treatment? As the water is evaporated below 75 degrees Celsius, it may contain bacteria which can be harmful for human consumption. Thus, it requires sterilization before use. Classification of drinking water. Water with total dissolved salts less than 300 mg per liter is considered excellent. Between 300 to 600 is considered good. Between 600 to 900 is considered fair, and more than 1200 is considered unacceptable. Requirements of drinking water. World Health Organization has provided exhaustive guidelines on safe drinking water. On the basis of these guidelines, individual governments have laid down their own standards for drinking water. Bureau of Indian Standards has set specifications for drinking water IS 10500, which was last revised in 2012. Properties of drinking water. Properties of drinking water are split in three categories of essential, desirable, and undesirable. Among the essentials, odor should not be objectionable, taste should be agreeable, turbidity below 1 NTU, pH between 6.5 to 8.5, total hardness 200 mg per liter maximum, chlorides 250 mg per liter maximum, iron 0.3 mg per liter maximum, and absence of fecal coliform. The desirables include calcium 75 mg per liter maximum, magnesium 30 mg per liter maximum, sulfate 200 mg per liter, nitrate 45 mg per liter, and fluoride 1 mg per liter. Lead, arsenic, and cadmium beyond traces are undesirable. Treatment of drinking water. Although freshwater generator produces water of high purity, but it tastes flat as it does not contain any dissolved solids and has very little dissolved air which has been removed during distillation process. To make evaporated water suitable for drinking purpose, it requires mineralization and sterilization. Mineralization. The sketch shows the arrangement of freshwater storage on cargo ships and the method to mineralize drinking and washing water before filling in the tanks. Water is treated by passing it through a bed of limestone which provides it some hardness. In the presence of small amount of carbon dioxide liberated by the decomposition of calcium bicarbonate present in seawater. Evaporated water is led to distilled or technical water tank directly as it does not require any treatment. Cargo ships are equipped with two domestic water tanks and the sketch shows filling of number 1 tank. Rehardening filter is a cylindrical vessel consisting of granular calcium carbonate bed which is the source of necessary hardness and enriches the water with natural minerals. Water is made to flow through it at required velocity to provide appropriate contact time for achieving desired alkalinity and fine tuning the pH value. Cylindrical shell is equipped with inspection cover IC for renewing calcium carbonate and connections for inlet I, outlet O, vent V and relief R and drain D. Rehardening filter has long service life and the calcium carbonate bed may be renewed when its effectiveness is reduced. Chlorination plant. The sketch shows a chlorination plant found on some ships which are equipped with a separate tank and hydrophore for drinking water. Chlorine is most effective chemical for destroying any likely contaminant which can be present in seawater. Chlorination is often used on ship for disinfection of drinking water. After passing the evaporated water through rehardening filter, drinking water is led through the chlorinator where the venturi automatically regulates the quantity of chlorine before it is stored in the tank. Chlorine is usually added as a solution of sodium hypochlorite, that is bleach liquid. Approximate quantity to be added is 1 liter of 10% strength for every 100 ton of water so as to get a residual chlorine content between 0.5 to 2 parts per million. The effect of chlorine disappears after a certain time as residual chlorine gets dissipated within a week. Thus, chlorine tablets need to be added in the drinking water tank regularly to keep the water disinfected during the storage. Hydrophore pump keeps the drinking water hydrophore pressurized against the compressed air pressure in the top. Hydrophore pump is started and stopped by the pressure switch and water level is monitored through the gauge glass. Relief valve protects the hydrophore tank against overpressure. Water from hydrophore is filtered by passing it through a bed of sand. Chlorinated water is not very pleasant to drink. Therefore, residual chlorine is removed by passing it through activated carbon in the carbon bed filter. Drinking water is finally supplied to the drinking water taps or cooler fountain. Silver ion or electrocatadin method. The sketch shows silver ion method, which is an alternative to chlorination and involves the use of driven silver anode to inject silver ions into the evaporated water used for drinking purpose. Silver is toxic to the various microorganisms even in low concentration such as 0.005 parts per million. Unlike chlorine gas, it does not evaporate but remains suspended in the water. The sterilizer consists of a electrolytic cell formed by cathode and silver anode, placed close to freshwater generator and rehardening filter is installed between sterilizer and the storage tank. Water is made to flow through the electrolytic cell. Low voltage DC current is regulated to flow through the consumable silver anode in the electrolyte cell to release the required silver. While treating large volume of water, only a part is passed through the sterilizer and the high current is used to inject a large amount of silver. The bypassed water is then added to the rest in the pipeline. In small systems, all the water is passed through the sterilizer and the current is set to get silver concentration of 0.1 parts per million. The silver content of domestic water should be 0.08 part per million maximum. Silver anode has reasonably long life but it requires periodic cleaning. Effectiveness of sterilizer is monitored by measurement of silver ions in the treated water. Ultraviolet sterilizer. Ultraviolet light can be used as an effective means of sterilizing water without causing any physical or chemical change in the water itself. The unit is fitted on the discharge side of freshwater hydrophore in a stainless steel irradiation chamber so that the water is sterilized immediately before use and any contamination of microorganisms during the storage has been eliminated. The UV sterilizer is equipped with low pressure UV lamps in quartz jacket, powered by electronic high frequency ballasts for high efficiency and low power consumption. Tubes are wired in series with a transformer for safety. The sterilization process is controlled by microprocessor through UV monitor. A wiper is fitted within the chamber to clean the jacket and lamp observation window. In case of lamp failure, solenoid valve shuts the inlet water supply and displays the warning signal. UV lamps have fixed life which is counted by the hour meter and lamp needs to be changed when the limit is reached. The sterilizer is equipped with a drain valve D and vent valve V for use during the maintenance and repair. This completes the study of suitability of evaporated water for drinking purpose and the necessary treatments required before use. This book is written by me and covers all the topics as per the syllabus specified by Indian Maritime University. It clarifies the concepts with simple illustrations. The book also provides answers to all the questions which have appeared in the examination conducted by Indian Maritime University. The book can help the students in preparing for the exam and also to work on ships, auxiliary systems, and deck machinery safely. Hope that you have liked the lecture. You can write your feedback in the comment box. If you have liked the tutorial, you may share it with your friends. You may subscribe to the channel for getting notification about the new tutorials. I will be back with a new lecture shortly. Thanks for watching till the end.